Hello students, today we are going to do probability distribution. Before doing the probability distribution, we have to know about the meaning of probability. So here the meaning of probability is basically the probability is the possibility of outcome of an event, and it is the likelihood or chance of occurrence of an event. And the probability of happening of an event is known as success, and the probability of non happening of an event is known as failure. After going further, we should know about the basic concepts of probability. So here is our first concept, that is the experiment. Here from experiment we mean when we conduct a trial to obtain some information, to obtain some data, then it is called an experiment. For example, we are tossing a coin to getting the head or tail. If we are rolling a dice to getting the 1, 2, 3, 4 and 5 and 6, then it is known as experiment. After experiment we should know about the event. The event is the possible outcomes or conclusion of an experiment or trial is known as event. For example, if we tossing a coin, then we got the head or tail. The head or tail are events, and if we rolling a dice, then the possible outcomes are 1, 2, 3, 4, 5 or 6. So these are our events. Next is exhaustive events. The exhaustive events are the total number of possible outcomes of a trial are called exhaustive events. For example, if we are rolling a dice, it includes 6 possible outcomes, 1, 2, 3, 4, 5 or 6. These are the exhaustive events. So basically exhaustive events includes all the possible outcomes. So our next concept is equally likely events. Equally likely events are those events which has equal probability. For example, if we are tossing a coin, then the probability of getting the head is 1 by 2 and the probability of getting the tail is also 1 by 2. Then these events are known as equally likely events which has equal probability. After that, our next concept is mutually exclusive events. Mutually exclusive events are those events which cannot happen simultaneously in a single trial. They cannot happen at a particular time. You cannot get the two things at the same point. So these events are mutually exclusive events. So that is independent events. Two events are said to be independent if the occurrence of one does not affect or affected by occurrence of another. For example, if we are rolling a dice twice, the occurrence of 4 in first row is not dependent on the occurrence of 6 in second row. Let us take another example. If we are tossing a coin 2 times, so the probability of getting a head in first row is not dependent on the probability of getting tail in second row. That is independent events. So next is dependent events. Dependent events are that events which depends on each other. The occurrence of one affects the occurrence of another. That is the dependent events. For example, if a card is drawn from a pack of 52 cards and without replacement, this will affect the probability of second card being drawn. So these are the dependent events. Next is simple and compound events. Simple events involves happening or non-happening of a single event. Compound event involves happening or non-happening of joint occurrence of 2 or more events. Let us take an example. If we have only one coin and we would like to know that probability of getting the head or tail, then it is a simple event because there is only one coin. If we have 2 coins or 3 coins or 4 coins or 5 coins, then it is known as compound events. In the same sense, if we are rolling only one dice, then it is simple event. If we are rolling 2 dices, then it is compound events. After simple and compound events, the next concept is complementary events. Suppose we have only 2 events, A and B. So we can say that A is called the complementary event of B and B is called the complementary event of A. Later on we would explain in next slide in detail this complementary. Our main topic is theorems of probability. There are three theorems of probability. First is addition theorem, that is second is multiplication theorem, and third is Bayes theorem. And today in this lecture we will do only addition theorem. So addition theorem states that if A and B are mutually exclusive events, then the probability of occurrence of either A or B is the sum of the individual probability of A and B. So basically I told you earlier what are the mutually exclusive events. You can read from previous slides what are the mutually exclusive events. So if mutual exclusive events are there, but they cannot happen simultaneously, that are mutually exclusive events. If mutually exclusive events are there, then we have to calculate the probability of two events individually. After calculating the probability of that events, then we have to add their probability. Suppose we have two events A and B, then we have to calculate probability of A and probability of B. And when we add the probability of A and probability of B, then we can get the probability of A and B both. So if three events are there, A, B, C, then we have to add the probability of A, B and C. So let us take an example. For example, if a card is drawn from a pack of 52 cards, what is the probability of getting either a king or queen? I would like to tell you that in 52 cards there are 13 cards of spade, 13 cards of diamond, 13 cards of heart and 13 cards of club. You can write on your notebook and you can remember this, कि 13 spade, 13 clubs, 13 hearts, 13 diamonds are there. And in these 13 cards, one is king, one is queen. So basically there are four kings, one of spade, one of club, one of heart and one of diamond. Four kings are there. So the probability of getting a king, that is 4 by 52. And in the same sense, probability of getting the queen is also 4 by 52. So the probability of getting either a king or queen, that is 4 by 52 plus 4 by 52, that is 8 by 52. If you cut them, then the answer would be 2 by 30. So our next topic is addition theorem in case of not mutually exclusive events. So let's suppose previously we have done addition theorem in case of mutually exclusive events. Now let us imagine if events are not mutually exclusive, then what will happen? It means if two events happen simultaneously, then what will we do? Then there will be the another formula. There is a slight change in the formula of addition theorem that we will understand in the from the help of the example. Let's suppose a card is drawn at random from a well shuffled pack of cards. What is the probability of either a spade or a king? Previously we got the probability of either a king or queen. We know that king is separate and queen is separate. There are four kings, four queens. They are mutually exclusive events. They cannot happen simultaneously. मतलब एक साथ किंग और क्वीन आना पॉसिबल नहीं है. बट लेकिन जो स्पेड और किंग है उनमें एक आपस में रिलेशन है. दे आर रिलेटेड टू ईच अदर. हाउ? बिकॉज आई टोल्ड यू अर्लियर कि स्पेड 13 पत्ते होते हैं स्पेड के. देयर आर 13 कार्ड्स ऑफ स्पेड और उसमें एक किंग होता है. तो ये प्रोबेबिलिटी हो सकती है कि वो जो एक किंग आए वो स्पेड हो, वो स्पेड का किंग हो सकता है. तो दे कैन हैपन साइमल्टेनियसली. तो ये म्यूचुअली एक्सक्लूसिव इवेंट्स नहीं है. इस केस में फॉर्मूला थोड़ा सा चेंज हो जाएगा. फॉर्मूला होगा प्रोबेबिलिटी ऑफ ए प्लस प्रोबेबिलिटी ऑफ बी माइनस प्रोबेबिलिटी ऑफ ए बी. सो हमें प्रोबेबिलिटी ऑफ ए और बी पता करनी पड़ेगी. पहले उन दोनों को ऐड करके उसमें से प्रोबेबिलिटी ऑफ ए बी डिडक्ट करनी पड़ेगी. सो द प्रोबेबिलिटी ऑफ ड्राइंग अ स्पेड, एज यू नो there are 13 cards of spade, so probability would be 13 upon 52. Next is probability of drawing a king, that is 4 by 52 because 4 kings are there, and probability of drawing a king of spade, that is 1 by 52. So after putting the value, probability of A 13 by 52, probability of B 4 by 52 and probability of AB, that is 1 by 52. So that answer is 16 by 52. और 4 के टेबल में अगर कटिंग करेंगे तो आंसर आ जाएगा 4 by 13. सो दैट इज आवर एडिशन थ्योरम. अगर आपको इसमें कोई भी दिक्कत आती है, इफ यू हैव एनी डाउट, एनी क्वेरी, देन यू कैन इंक्वायर मी टेलीफोनिकली.